A square matrix A is called a nilpotent matrix. A square matrix A is called a nilpotent matrix if there exists a positive integer. If there exists a positive integer m such that a power m is equal to 0. Nilpotent, that is the potency to bring a nil matrix, that is a 0 matrix, is called a nilpotent matrix. So, if there exists a positive integer m for which a power m is a 0 matrix, then we call A as a nilpotent matrix. And the least value of m, the least possible m, is called the index of the particular nilpotent matrix. That is, if you have a matrix A. So if you want to check whether it is a nilpotent matrix, so you have to go on raising A to higher and higher powers. So if at some stage A power something has turned out to be 0. For example, A is a non-zero matrix. For example, A square, again non-zero matrix. A cube, again non-zero matrix. But for example, if A to the raise 4 has become a 0 matrix. For suppose A to the power 4 is a 0 matrix. A square, A cube are non-zero matrices. So once A to the 4 is equal to 0, all the higher powers will turn out to be zeros, because A5 is A4 times A. So A4 is 0. So 0 matrix into any matrix is 0. So once for some index, A power that index becomes 0, all the higher powers will turn out to be zeros. And the least possible m, that is the first power where A power m becomes a 0 matrix, is called the index of the matrix. Index of the matrix. For example, if you have a matrix 0, 1, 0, 0, this is a matrix A. So if you find A square, you can see that it turn out to be 0. And once A square is a 0 matrix, A cube, A4, A5, all the higher powers will be 0 matrices. Now, what is the index of this nilpotent matrix? 2 is the index of this nilpotent matrix. 2 is the index of this nilpotent matrix. So I hope this is clear. And one of the important properties of nilpotent matrices is that a nilpotent matrix should always have a determinant of 0. A non-singular matrix cannot be nilpotent. So a matrix A is nilpotent implies that A is singular. That is, determinant is equal to 0. But reverse is not. Determinant is equal to 0 does not imply a nilpotent matrix. But nilpotent matrix implies that the matrix A has determinant is equal to 0.